Okay, so this is the artificial sky, and as we were talking about in the lecture this morning, this is completely different from looking at direct sunlight. This is now simulating a daylight factor condition, so it's an overcast sky. And that's why we've got this sort of diffuse lighting arrangement above our heads. So it's diffuse so that hopefully we don't get any shadows from it. And the mirrors all around is a sort of a reasonable way of simulating the hemisphere of the sky, reflecting light. Okay, obviously we can't, well, it'd be very difficult to build a hemisphere clad in mirrors, but you know, sort of rectangular mirror arrangement works just as well. Okay, so we're going to look at daylight factor, and I've got a model here. Now this is a really excellent model, which I think is 1 to 20 looking at it, but you don't have to have a model this big. Okay, 1 to 50 normally works perfectly well. 1 to 100 you might struggle. It might just be a bit too small. Okay. Now the thing about the artificial sky is we're only interested in the interior of the building. So for this purpose we're not at all bothered on the outside of the model, which is why you can see there's bits of sticky tape and you know, markings. It doesn't matter, because that's not what the point is. Not to say that you couldn't potentially make a model which would do both, which could be a sort of external model and an internal model. But quite often it's quite quick to build an interior model, but as soon as you're trying to make the outside of the model look kind of accurate, that's a lot more time. Alright, so you can't all see in it yet, but you can all have a little look later. But this is a very well made model, and I won't turn it around, it's quite big. It's actually got people in it, which are cardboard cutouts, and it's got some of the artworks. It's a gallery space. And what's great about this model is the student used this for the artificial sky, but they also used it as a kind of design visualization tool. And they got some incredibly accurate photographs of the interior, which were, you know, very, very useful for their presentation. Okay, but we're going to use it for daylight today. So, one thing is we've switched the artificial sky on, and we've given it about 10 minutes to warm up. It does take a little while for the lighting to reach its optimum level. If you try and test before that, you'll get some odd readings because the lighting will be getting brighter and brighter while you're using it. Okay. And we've got a light meter, which I'm just assembling here, and it has a probe on it. Okay, you can borrow these from here, of course. And on the outside of the artificial sky is a little bit of guidance about how to use it and the calculation. But I've also got an online worksheet tool which I'm going to use today. Now I'm afraid you're not all going to be able to see it, but I'll have to spin it around. And that's an online simple sheet that I've devised, which you can use on an iPad or a laptop or an iPhone, in fact. Okay, it's just a simple way of recording. So, if I just open this worksheet, and I'll spin it around. So what we've got, I'll spin it around just a second. You probably can't see this on the camera, but I'll put a still in anyway. So let me just spin it around now. It's quite simple. You've just got a means of recording what you're doing. It's not a sort of fancy graphic or anything. It's just a spreadsheet to record your data. So what you've got is you've got the rough layout of your room here, which you need to measure, you know, and just sort of draw that as a rough box as accurately as you want. You've got a few factors to put in there, which are the glazing factor, the glazing bar factor, and the maintenance factor. Now what those factors are all about, it's simply the fact that your cardboard model does not normally have glass in it. So these windows are completely transparent. In a real building, you've got glass which absorbs some daylight, you've got glazing bars, and you've got a bit of dirt, a bit of muck on the windows. So there are some typical factors which are already in the worksheet, and they just give you a slightly more accurate reading. Okay. Right, the other thing I should say is normally just come in here one or two at a time, because what we're actually doing is like, we're like big giants now in this world. Okay, so we're, you know, the light that you would normally get through that skylight, we're all absorbing it, and yeah, we would slightly distort the readings. So just come in here one at a time. You don't need to wear a white coat or anything. I don't think it's that accurate. Okay, so what we'll do, first of all, we've got our light meter. We need to get the external illuminance level. So what's the light level outside? I'm just going to pop that on the top, and I'll wait for the light reading to settle down a bit, and it's telling me 4600, 4,600 lux. And I'm just going to input that in to my spreadsheet. Okay, you could just write that down. You could just do it manually. The worksheet makes it a little bit easier. So we need that level, and that won't change. Because it's a constant sky, that won't change, unless we all went out of the room, and then it would change a bit. And then what we need to do is take some readings inside the building, and you need to decide your sort of level of accuracy. So do you want a grid of readings, or do you just want a few readings? You just want 3 or 4 readings to get an overall feel for the daylight in there. On the worksheet, you can play with it later if you want, but there is a parameter where you can set the scale unit. At the moment I've got that set to 0.5 meter, which just means that these little boxes in my worksheet represent 0.5 meter in the model. You can change that, and what you then do is you're simply going to put the light meter in, and I find what I normally do is just blue tack that to a penny or something just to weight it down, but I forgot. Just makes it stay in place a bit. So I've popped that in, and I'm getting a reading. It's just settling down, and that's giving me a reading of 1122 lux. So I'm going to go to my worksheet here, 1122, and input that. To be more accurate, you would probably want to get a tape measure, or you know, or just put a grid of paper in, or just something so you can be slightly more accurate. But you know, you don't need to be too obsessed with accuracy on this, as long as you're roughly in the right area. And then I'll just move the meter across, and we've got 1134, and we proceed throughout the building, taking readings. Now, actually in this model, there's so much glazing, it's a very uniform daylight inside it. So I suspect we could probably put this daylight probe anywhere within the model and get a fairly similar reading. That's gone up there, that's 1565. So input that. The other thing with this model, which I suspect is a mistake, is this whole end of the model is open. Now I think that's meant to adjoin onto another building, so what you really should have done here would be to mask that off with a piece of paper. You cut a little hole to put the probe in, because we're probably getting some, unless that is meant to be glass, we're maybe getting some slightly odd readings there. And that's the process. Go through taking lux readings. Now, you can then either manually, using the calculation of daylight, the internal illuminance over the external illuminance times by the glazing factors will give you a daylight factor. The worksheet that I have does it for you. So if you go to the second sheet, I'll just hold that up, it translates those illuminance level figures into a daylight factor for you. And you can colour code the results however you wish. So it's just a shorthand, so you don't have to sit doing lots of calculations. And so what I'm looking at there is that the daylight factor readings I was inputting were 13%, 18%, very well daylit room, which you probably would expect with these enormous windows, white surfaces throughout. It's a very bright space. But if you were doing a model with you know, with smaller windows, you'd be getting much lower results, and you could be quite careful about that. Now, what I should say is your material surfaces need to be reasonably accurate, not exactly accurate, but you know, the colour of them, get it approximately right. White walls or, you know, a grey floor helps, and that will give you a better sort of accuracy. Now the other thing I would say is, really, if you're going to use this as a design tool, you need to have a model that you're quite happy to change. Because otherwise you're just getting a set of results, but you're not going to do anything with it. So for example, if this was my model, maybe you might take some readings and you might cover over one of the skylights and retest it and see how the kind of daylight factor is working with it with a different configuration. Okay. Any questions before it gets too hot in here? Is that all right? Okay, good. I mean, I apologise, you can't all see the worksheet here, but it's available online, and you can download it and you can customise it how you want, or just fill in the figures. It's not giving you a sort of amazing, amazingly beautiful output. It's a technical output, but if you wanted to do something, more sort of graphic with that, you could always take that into Photoshop and underlay it under your building plans, or do whatever you want with it.